Learning about the Data Encryption Standard, DES, can be an exciting journey into the world of cryptography and data security. Especially when we are moving into a world of technology such as cloud solutions, securing data is not just an option but a necessity. However, many people stumble along the way due to a few common mistakes while learning DES. Whether you're a beginner just starting out or someone with some background knowledge, it's essential to steer clear of these pitfalls to understand DES and its implications truly. Here's a closer look at 5 mistakes to avoid when diving into DES. Skipping the basics of cryptography. One of the most significant mistakes learners make is diving straight into DES without grasping the basic cryptography concepts. Cryptography is a broad field, and understanding terms like encryption, decryption, plaintext, ciphertext, and keys is crucial. When you don't have a solid foundation in these concepts, it's easy to become overwhelmed by the complexity of DES itself. For instance, if you don't understand the difference between symmetric and asymmetric encryption, how can you appreciate why DES is considered a symmetric algorithm? Solution: before jumping into the details of DES, take the time to familiarize yourself with the basic terminology and concepts of cryptography. Plenty of online resources, books, and tutorials can help you get started. Once you have a solid understanding of the basics, you'll find it much easier to comprehend how DES fits into the larger picture of encryption methods. Underestimating key management. Another common pitfall is underestimating the importance of secure key management. Many people believe that just knowing how DES works is enough, but a weak or improperly managed key can compromise the security of encrypted data. If someone gains access to your encryption key, they can easily decrypt any data that was protected using that key. In practice, you need to think carefully about generating, storing, and distributing your keys. Solution: learn about best practices for key management. This includes using strong, random keys, storing them securely, perhaps using a hardware security module, and implementing procedures for only distributing keys to authorized users. The security of your encrypted data heavily relies on how well you manage your keys. Assuming DES is still secure. A third mistake many learners make is assuming that DES is still a secure standard today. While DES was groundbreaking when it was introduced in the 1970s, advancements in computing power and cryptanalysis have rendered it largely obsolete. Modern brute force attacks now easily break the 56-bit key length that was once considered sufficient. Many people might still come across references to DES in textbooks or online, leading them to believe it's still a viable option for securing data. This misconception can be dangerous, especially in fields like finance, healthcare, or any area where sensitive information is handled. Solution: recognize that DES is considered insecure and should not be used to protect sensitive data today. Instead, take the time to study modern encryption standards like the Advanced Encryption Standard, AES, which offers significantly stronger security with longer key lengths. Neglecting practical implementation. While theory is essential, neglecting practical implementation is another common mistake. Learning about DES in a theoretical context without applying that knowledge in practice can lead to misunderstandings about how the encryption process works in real-world applications. Many people might still come across references to DES in textbooks or online, leading them to believe it's still a viable option for securing data. This misconception can be dangerous, especially in fields like finance, healthcare, or any area where sensitive information is handled. Solution: recognize that DES is considered insecure and should not be used to protect sensitive data today. Instead, take the time to study modern encryption standards like the Advanced Encryption Standard, AES, which offers significantly stronger security with longer key lengths. Neglecting practical implementation. While theory is essential, neglecting practical implementation is another common mistake. Learning about DES in a theoretical context without applying that knowledge in practice can lead to misunderstandings about how the encryption process works in real-world applications. If you only read about how DES operates without experimenting with actual code, you might miss out on essential details like how different key sizes affect encryption speed or how to handle errors during the encryption and decryption processes. Solution: get your hands dirty with practical coding exercises. Use programming libraries that implement DES, such as Python's PyCryptodome or Java's javax.crypto, and try to encrypt and decrypt some sample data. This hands-on experience will solidify your understanding and help you see how DES functions beyond the theory. Not understanding vulnerabilities. Finally, many learners fail to study the vulnerabilities associated with DES. Understanding DES's weaknesses, including its susceptibility to brute force attacks and certain types of cryptanalysis, is essential to grasp why it has been phased out in favor of more secure algorithms. Some people might learn about DES in a vacuum and not explore the historical context of its use and eventual decline. This lack of awareness can lead to misunderstandings about the broader field of cryptography and how it has evolved. Solution: research DES's vulnerabilities and learn about the types of attacks that have been successful against it in the past. This knowledge will help you understand why DES is no longer considered secure and provide valuable insights into how to evaluate and choose secure encryption methods for the future. In summary, when learning about the Data Encryption Standard, DES, avoiding these common mistakes can significantly enhance your understanding and application of encryption principles. Focus on grasping the basics of cryptography, managing keys securely, recognizing the limitations of DES, engaging in practical implementation, and understanding its vulnerabilities. By doing so, you'll be better prepared to navigate the complex and ever-evolving landscape of data security and encryption.